This is number 13 from section 8.4, and it's with the M&Ms again. And I may have done these in one or both of the classes, but I'm going to repeat it again because some people are asking for it, asking to see this one worked out. So, we have in this problem the following information. A random sample of 19 green M&Ms. Their mean weight is 0.8635. The sample standard deviation was 0.0570. And we're going to use a significance level of 0.05 to test the claim that the mean weight of all green M&Ms is equal to 8535. So, what does that tell us? Well, let's go ahead and put this information up here where we can refer back to it as needed. But let's see how we can state what our null and our alternative hypotheses are. The claim we want to test is the mean weight is equal to 0.535. And since the alternative hypothesis, the mean hypothesis is always the one that contains equality, not only is our null going to be the mean is 0.8535 grams, this is also going to be our claim. And the alternative hypothesis is going to be that the mean is not equal to 0.8535. Okay, because I don't care which way that it may be above or below 0.8535. If the claim is wrong, all we have to show is that it's not equal to 0.8535. So this is going to end up being a two-tailed test. Okay, the distribution is going to have two different tails on either end, which we'll see in just a second when we draw the picture. But at any rate, since we're doing a hypothesis test with, we're testing something about a mean, a single mean, and we don't know the standard deviation, this is just the t-test, the one that we do in this class. So if we calculate the test statistic, t is equal to x bar minus mu over s over root n. That is equal to 8635 minus 0.8535, all divided by 0. All divided by 0.057 divided by the root of the sample size, which is 19, and the degrees of freedom are going to be 18. So I'm pretty confident that everyone can do this calculation, but that's what you would plug into your calculator, and we would get that the test statistic, once you do the calculations and look on the table at your degrees of freedom, is t equals 0.765. Now, if we look at the table to find out what our critical value is, from the table, the critical value is going to be t equals 2.101. But remember, this is a two-tailed test, so we're going to have two different critical values. So the distribution looks something like this. And our critical values are going to be 2.101 and negative 2.101. So I'm going to have two rejection areas. And just notice that since our significance level is 0.05, that 0.05 is split up into both of these tails. So an individual one will have an area of 0.025. Okay. Now, do we reject or do we not reject? Well, we look and see where our test statistic falls. Our test statistic is only 0.765, so that's about right here. Okay, so it's not in the rejection region, so we would not reject H naught. That is, we're not going to be rejecting our claim. So we do not reject H naught. And then you write up your conclusion in the usual way. There is sufficient evidence to support our claim. Now, if you want to calculate this using the p-value method, you again use technology. Be the best way, and you would get that p is equal to 0.4543. And yeah, p is certainly bigger than our significance level. So again, we wouldn't reject H naught. Okay. If you have any questions, let me know, and I can try to clear them up. Okay, so this is number 15 from section 8.4. The problem, which we may have done in class, and at least one of the classes, I'm going to go ahead and redo it now. Says 40 people used Weight Watchers for 1 year, and their mean weight loss was 3 pounds. And the standard deviation for that sample was 4.9 pounds. And we want to use a 0.01 level of significance to test the claim that the mean weight loss is greater than 0. And then we answer the question, does it appear to be effective? Is it practically significant? So we have that n is equal to 40 in this problem. So we want to go ahead and do a hypothesis test. So if we put that information up there, the first thing we need to do is form our two hypotheses. So since the claim we're testing, does the mean weight loss appear to be greater than 0? So the null hypothesis, H naught, would be that the mean weight loss is equal to 0. And the null hypothesis would be the mean weight loss is greater than 0. And this one turns out to be the claim. Right. So since we are working with a mean and we don't know the population standard deviation, this turns into a t-test. So that means that our test statistic is going to be t equals x bar minus mu divided by s over root n. And if we plug everything in, this is going to be 3.0 minus 0 divided by 4.9 over root 40, and the degrees of freedom are going to be 39. So once we do that calculation, we'll get that the test statistic t is equal to, this is just plug and chug, it's going to be 2.426. That's our test statistic. And then you can use the table and see that the critical value for this going to be t equals, the critical value is 2.426. The test statistic is different. The test statistic turns out to be, what is that? It is 3.872. So if we draw the distribution here, whoops, that is a really sad looking line. Let's try that again. If we draw the distribution, well, where's our critical value? It's right about here. Okay. So this is my critical value. And where does my test stat fall? My test stat is 3. It's bigger than 3. So my test stat is going to be somewhere right here. And then we'll call that red region, this red shaded region here, this is going to be our rejection region. Since the test statistic does fall in our rejection region, well, that tells us that we will be rejecting H0. Reject the null hypothesis. Okay? And then we can sum up, how to write this up. There is evidence to support the claim that Weight Watchers leads to a mean weight loss greater than 1. Now, if you want to do this with the p-value method, the best way to do that is to use technology. The p-value, p is going to be equal to 0.0002, which is certainly less than our significance level alpha. So you would reject H0 in both cases. Now we need to address what the last part of this question is asking. Is this clinically significant? Is it practically significant is what it's asking. This addresses the question of what's called clinical significance. So let's talk about that for just one moment. What we've shown is that there is sufficient evidence to show that there's a weight loss greater than 1. Okay, that the mean weight loss is going to be greater than 0. Okay, but the only weight loss we found was a mean of 3.0 in an entire year. Okay, now your weight going down by 3 pounds is in an entire year is not what we would call clinically significant. Okay, even though there's a statistically significant difference if someone uses Weight Watchers, there is not a clinically significant difference because 3 pounds is not that very much. So the diet does appear to be effective if all you want to lose is 3 pounds. So there's not much practical significance to this. All right. So that answers the question. If you have any questions or comments about this, let me know and I can update this. And here's number 25 from section 8.4. So in the back of the book and on my math lab, you can download this data. There is information for 50 earthquakes, and here is the magnitude of those 50 earthquakes. We want to test the claim that the mean magnitude is greater than 1, that the population of all earthquakes has a mean magnitude greater than 1 at the 0.05 significance level. So I'm not going to go through all the details again. I'm confident you guys by now that you can do that. But our null hypothesis is going to be the mean is equal to 0. The alternative, the mean is greater than 0. This is the claim. So to get your test statistic, you'll have to find the the sample mean and sample standard deviation of this data. So you would do that with technology. And you'll get that your test stat turns out to be 2.218. Then using 49 degrees of freedom, the critical value is going to be 1.676, which is going to put it right here as a left-tailed test. The test statistic is going to end up being somewhere over here, right, which is in the rejection region. So that tells us, since the test statistic is in the rejection region, yeah, we would reject H naught. Okay, so there is evidence to support the claim that the mean earthquake magnitude is greater than 1. And if you use technology to calculate the p-value and use the p-value method, you'll get a p of 0.0156, which again, since this is less than alpha, we would reject the null hypothesis and say that there is evidence to support the claim. Right, so that is number 25 from 8.4. Again, if you have any questions, please let me know.